Standard design of experiments can trap you. You have specific real-world constraints, but traditional methods often force you to fit your physical laboratory into rigid textbook templates. JMP's custom design platform reverses that dynamic. It builds the experiment directly around your budget and your technical limits. Consider a Pinot Noir wine production process. Testing every combination of our 9 processing factors requires 1,024 separate runs. We only have the budget for 40. This chart is the grayscale color map on correlations. It is a professional evaluation tool you will master during this tutorial. Mastering these tools reduces experimental budgets while maintaining the mathematical proof required to validate your data. Step 1 is Setup. Navigate to the DOE menu and open the custom design platform. We start by defining our response. We name it rating, set the lower limit to 0 and the upper limit to 20, and keep the goal set to maximize. Next, we enter the 9 categorical factors that impact our wine processing, variables like grape variety, temperature, and yeast type. Now we hit a real-world human constraint. We have 5 expert wine raters, and each can realistically test only 8 wines. We translate that human limit directly into the software by adding a blocking factor and setting it to exactly 8 runs per block. To guarantee your results match this tutorial exactly, open the red triangle menu, set the random seed to 100526291 and the number of starts to 2. Here is the crucial budget step. Under Number of Runs, override the default by typing exactly 40 into the user-specified box, then click Make Design. This generated data table displays our runs. Looking at the rows, we can verify that the software successfully built a matrix where each of our 5 raters evaluates exactly 8 unique wines. The platform just calculated over 1 billion possible combinations to output this flawless, constraint-perfect 40-run schedule. Before we run the physical experiment, we need to mathematically audit its integrity in the design evaluation section. This is the color map on correlations. The 15 squares in the top left corner represent our main experimental effects. Pure white indicates 0 correlation, meaning the effects are perfectly orthogonal. The black diagonal line simply shows each element perfectly correlating with itself. To check for hidden biases and interaction effects, we use this table, the Alias Matrix. Let's read a specific intersection. Look at the value where barrel seasoning meets the variety by press interaction. That 0.4 means if the variety by press interaction is active, it will artificially skew our barrel seasoning data by exactly 40%. Understanding these visual diagnostics prevents your team from making false discoveries, ensuring complete confidence before you spend your physical budget. Once the physical experiment is complete, we transition to our core analysis engine, the Prediction Profiler. This chart is the Profiler UI. By clicking Maximize Desirability from the red triangle menu, the software instantly reveals the best possible wine recipe, yielding a peak predicted score of 18.725. But manufacturing realities hit roadblocks. Suppose optimal Dijon grapes are out of stock and we must use Bernard. We move the variety slider to Bernard, lock it, and rerun the optimization. The system instantly recalculates the peak outcome. This adaptability applies to broader industrial concepts as well. Some physical factors, like furnace temperatures, cannot be easily changed between every single run. By simply changing a factor's status from easy to hard in the initial setup, JMP automatically builds complex split plot or split-split plot designs to accommodate that physical reality. The software adapts directly to the physical, financial, and logistical realities of the busy factory floor, allowing you to scale efficiently. We defined our variables, applied human rater blocks, condensed 1,024 potential runs down to 40, and profiled the exact optimal outcome. This process replaces expensive guesswork with a statistically validated experimental plan. To master these tools yourself, open the winedata.jmp file located in your sample data folder and recreate the exact steps shown today. You are now ready to engineer highly customized, budget-efficient experimental designs for your own operations.